We accept the reality of the world with which we're presented. It's as simple as that.
All right, hello and welcome everyone. Welcome to GLOBEBUSTERS episode 6 of season 13. Today we're joined by Beasticles, Shane St. Pierre, Dr. Mike Heffron, and Good Times for All, Zachary Zimbala, and I think is Cami with you, sir? Shout out to Cami, riding with Zach. Hey, Cami. Today we have an awesome presentation from Dr. Mike Heffron, who I'm going to introduce here in a second. He's going to tell his story. So yeah, a couple of years ago, it was a couple of months ago, Eric was our librarian, the EtherCause librarian. Eric was searching YouTube for ether videos and stuff, and he came across Dr. Mike Heffron's work. He had a couple of videos out on his ether theory, so we reached out and invited him to EtherCause to do a Prezi and discuss his thoughts on that. He's been a part of the community for several months now. It's been hanging out. And he's a former globe believer. And when he came into the community, he heard us arguing about, flat earth and, saw different things and started watching our content and then started, verifying it for himself. So he decided to take his own measurements. And from there, I'll kind of let Dr. Mike bring his story in. So if you want to start with, a little bit of your background and history and how you came about us here.
I have roughly 50 years of involvement with satellite technology before I retired. I retired the day the Space Force began, about 5 years ago. And as you can imagine, I was very, very heavily indoctrinated in the belief that the Earth is a globe. And so I came to ether cosmology, believing that Earth is a globe. Deep down inside, my personality is that of a scientist. And in fact, reading Alan's philosophy, that sounds like me. So it's almost as if we're kindred spirits, and we believe in experimenting and testing hypothesis. And so I've been promoting the null hypothesis, of course, and I'll get into that in the presentation. But I had a lot to overcome, but and I'm still far from being up to speed. But I've been listening to as many presentations as I can fit in between rescuing dogs and feeding them and taking care of them. I was doing that before I retired, and I've kept rescuing dogs after I've retired. Dogs are just really great animals to hang out with.
I agree.
Oh yeah,
They're just amazing. So is it
I
okay if
get-
I go into the
I get to
presentation?
go
or
say
would you
hi
like
to
a
my
little more
dogs right
background?
now.
Yeah, give me 1 second. I gotta fix this slide or how the screen share thing is happening.
You can focus people, right? Like you click on them, put them up on the top.
No, you're good. It's an OBS thing. I had the wrong scene selected. It should be updating now properly. There we go. Cool. All right. But yeah, if you want to get into your Prezi and what ended up becoming your proof, go ahead.
All right. So one of the interactions I watched was between Alan and a certain PhD who seemed to mistakenly believe that science is settled, and science, of course, is never settled, which is why we need to focus on the null hypothesis. But in watching the discussions, it seems we also need to go beyond the null hypothesis. And I want to invite people at any time during this presentation, please ask me to go back or clarify anything that seems unclear or confusing. And also feel free to interrupt at any time with questions. I realize I think differently than a lot of other people. I'm a big advocate of looking at things from the top down, from the bottom up, from the inside out, from the outside in, and occasionally just taking a leap right out of that box and come up with something entirely new. And because I'm looking at things from so many different perspectives, I'm kind of prone to say the exact opposite of what I'm trying to say. So if you catch me doing that, just call me on it right away and say, "Is that what you meant?" And I'm okay. I realize that's a problem I have because I'm just looking at things from too many directions at once.
Null hypothesis frame of mind. Got it. That's cool.
Yep. So with a hypothesis, the simpler your hypothesis is, the easier it is for you to defend. So you should always do your best to keep it short and simple. And it might seem like trigonometry should be simple enough to prove that the Earth is flat, but many factors may prevent even such a simple hypothesis from ever being proven to be true. For example, people like that certain PhD would probably interrupt on the third word and claim that the mountains in my drawing prove the Earth is not flat. Um, and in hearing many of the conversations, I'm realizing Globers can be pretty obnoxious, and it seems like clueless or intentionally misleading. Anyway, that's why it's important to instead refute the null hypothesis, which must be carefully worded as the exact opposite of the hypothesis you you wish you could prove. It's important to ensure that the hypothesis and null hypothesis are not merely opposite, but also mutually exclusive. So that if the null hypothesis is probably false, then the hypothesis is probably not false. And because the hypothesis may contain hunches or unstated assumptions, it can never be proven. And for example, this in the prior drawing that I had up clearly illustrate unstated assumption that flat doesn't mean free of hills and valleys. Instead, flat would be interpreted by most reasonable people as not the surface of an ellipsoid. And it's not necessary to complicate your hypothesis by stating it's not an ellipsoid, it's not a pyramid, it's not a square, etc. Because if your null hypothesis is true for any reason, your hypothesis is false. However, if your null hypothesis is false for any reason, then your hypothesis is probably not false. So in other words, the null hypothesis asserts that the hypothesis is wrong. And although it can be impossible to prove something is true, it can be relatively simple to demonstrate that something is false. And so we want to demonstrate that the null hypothesis is probably wrong. And if the null hypothesis is probably wrong, then the hypothesis is probably true. And because science is never settled, it's generally considered too strong a statement to claim that your hypothesis is probably true. So instead, we assert to some level of confidence that the hypothesis is probably not wrong. And if that seems a little confusing, please refer back to Ether Roundtable 63, and that will give you much more than this brief overview about the need for a null hypothesis. So
Yeah.
conveniently, this is
Quick
sorry, go ahead.
recap on. Yeah, I just wanted to quick reiterate on the null hypothesis, because it is one of the most fantastic ways of arguing ever. It's so it added a whole new like missing component to what we've been missing in this arena, and no one has even put forward like a rebuttal to what we've put forward. using the null hypothesis. So like a quick recap would be, you're going to assume your null hypothesis is true, and then you're going to try and falsify it. And if you can falsify it, then the alternative hypothesis that you put forward, which is supposed to be, the opposite of your null, will likely be the true thing. So if you do flat versus globe, very simple. If you can't falsify the flat, then the alternative, the globe, isn't true. So that's what we're going here. And then you get into the statistical significance of the analysis, et cetera, which if you haven't seen the ether cause Prezi from episode 63, I think you said it was, definitely go back and watch the intro to that, because Mike lays out a really nice introduction to the null hypothesis and its significance and how it's used in academia, so that when you're doing research for your PhD, you don't waste all your research, right? If you falsify the thing that you think is true, well, luckily you got a backup alternative that you just proved, so you're good to go, dude. So this is very significant here, and what is like in terms of like the methodology and the framework, and in terms of like having logic behind your position in science. So please continue.
Yep, and just to add just a tiny bit to that, the way my professors described it is, when you do it this way, if it turns out your hypothesis was wrong, all you do is swap your hypothesis with the null hypothesis,
You're good
and
to
then
go.
you've still contributed to the knowledge of humankind, which is what they expect from doctors.
Yeah.
So conveniently, this is a view of the Rocky Mountains from my driveway. This is overlooking the 10 acres of my front field. It's too generous to call it a lawn, because it's full of weeds, but if you don't look too close, it looks a little like a lawn. And these mountains look much more impressive when you're actually standing there. In this photo, they look kind of distant. It's amazing how much better our eyes pick up the details than cameras do. And the largest mountain peak in this photo is snowy Pikes Peak at the top center of the photograph. And what this means is I can easily perform some experiments thanks to my thin atmosphere here and the clear view to infinity and beyond. So it makes it really easy for me to experiment on how well these mountain peaks occlude stars. This is the close-up of the visitor center on top of Pikes Peak. The summit of Pikes Peak is very flat and it's pretty wide, and the visitor center is really easy to identify from far away using either a telescope or a theodolite, and I suspect even binoculars or one of those telephoto adapters you can add to your cell phone. All of those things would work really well spotting the peak. And at night, the observation room on the far left of the visitor center is lit, and therefore it's really easy to identify on the mountaintop even at night. And you'll actually see that in a video that'll be upcoming. I gave this website that's listed on this slide the latitude and longitude of Pikes Peak, so it could calculate the distance between me and Pikes Peak. And as an added benefit, it also calculated the initial bearing from my location and the final bearing from the peak. When you're looking along that straight line from my location through the summit of the peak. But for my first experiments, only the distance from my house is important. But that final bearing is going to become extremely useful in just a little while. And this particular website also gives a very detailed explanation of the math involved for those who want to really dig into the math. This is my original drawing to illustrate how I calculated that Pikes Peak should be at an elevation of 2 degrees, 31 arc minutes. And I never imagined that my original drawing would be too complex for Globers to understand. So the next, but that's either that's true or they're pretending that's true. But the next slide is going to align things more carefully and add notes in red to help clarify for the Globers the simplicity of what flat Earth really means. This is it. In theory, simple trigonometry should be sufficient for me to be able to refute the null hypothesis, because Pikes Peak is 50.7 kilometers from me and is 2,226 meters higher than the altitude of my lens. So simple trigonometry says a theodolite on a flat Earth should measure the ground level at the Pikes Peak Visitor Center to be 2 degrees, 31 arc minutes above a flat plane for my lens. And for some reason, from this diagram, they couldn't understand what that meant. So I hope these red modifications make this much clearer for Globers. The globe Earth expectations is very little, and plus they want to do all kinds of corrections that complicate things. But roughly 2 degrees, 17 arc minutes is a widely accepted value for what I should be measuring. And the null hypothesis concept holds me to the higher standard that the null hypothesis is deemed to be true, which means my hypothesis is false if the elevation of the visitor center is not the 2 degrees, 31 arc minutes expected for a flat Earth. So in other words, within the accuracy of my measurements, they need to clearly demonstrate that the null hypothesis is false by showing that I do indeed measure 2 degrees, 31 arc minutes. I found a well-used antique David White 8300 theodolite on eBay that cost me $65, including free shipping. A lot of people on the web claim this is the best model of theodolite ever made. And to anyone who may want to buy this one, this model to duplicate my experiment, you may want to pay extra to get its original tripod, because it has a very non-standard tripod, and it needs a really expensive, well, it's not that expensive, but it's like half the price of the theodolite to attach it to any modern type tripod. Instead of buying the tripod, I just stepped mine up on top of a very stable cabinet. So it wouldn't wobble around while I made the measurement, and that's how I kept my cost down to $65. The 8300 is slightly tricky to operate due to its many adjustments, and you can see some of them over there, the knobs. There's some really good YouTube videos about how to master this theodolite with just a little bit of practice. And another thing about the 8300 is it's slightly tricky to read because it has this vernier scale, but YouTube videos can help with that too. So to get accurate measurements from this theodolite, it's necessary to first adjust the theodolite for 0 degrees, 0 arc minutes as shown by this photo, and then carefully level it using the built-in leveling bubble. And after you've done that, the top scale indicates degrees, and the vernier scale on the bottom is accurate to the nearest 5 arc minutes, which is about 0.083 degree. And I think that's how it got its name, 8300, from its 0.083 accuracy. It will quickly become apparent why I didn't even try to get a good photo through the eyepiece of my 8300 theodolite, but this is a roughly equivalent photo of the visitor center, 4,300 meters above sea level at the top of Pikes Peak, taken from my SAR telescope. So the visitor center is 50.7 kilometers from the telescope in my sunroom in this photo. The lens of the telescope was 2,074 meters above sea level. So I got the altitude, latitude, and longitude of Pikes Peak from Wikipedia. I got the altitude, latitude, and longitude of the lens of my theodolite from the GPS waypoints application on my Android phone. What that all means is that the elevation of the visitor center should be 2 degrees, 31 arc minutes above my level if the Earth is flat, or about 2 degrees, 17 arc minutes above my level if the Earth is a globe. And remember that for the null hypothesis to be true, the elevation needs to be something other than 2 degrees, 31 arc minutes. On the first measurement, my theodolite measured 2 degrees, 30 arc minutes, which was the closest the accuracy would allow me to get to 2 degrees, 31 arc minutes. Thus, So within the accuracy of my theodolite, my very first measurement refuted the null hypothesis assertion that the Earth is not flat. So like I said, that is only one data point, but there's many more to come. But first, as we all know, critics are going to claim that the Earth only looks flat due to atmospheric refraction. And G.G. Bennett did a really good job in his 1982 paper, which he titled The Calculation of Astronomical Refraction in Marine Navigation. And in that paper, Bennett describes this equation for approximating the unsigned mean refraction in minutes of arc, where h is the observed altitude in degrees at a sea level air temperature of 10 degrees centigrade, a pressure of 1010 millibars. And that correction for refraction conveniently elevates the globe Earth prediction of 2 degrees 17 arc minutes to 2 degrees 32 arc minutes, which is consistent with my actual measurement to within the accuracy of my inexpensive theodolite. What an amazing coincidence that atmospheric refraction seems to account for the difference between flat Earth and globe Earth. So to refute the null hypothesis, Glober's claim I need to know the temperature and pressure of the air, and I really need a more accurate theodolite. Then the critics will claim that local gravitational anomalies skew the imaginary sea level plane between me and Pikes Peak.
He's
So
got it.
I need to get an even more expensive theodolite. And then the critics are going to claim that atmospheric distortions are skewing my measurements. So rather than refuting their own null hypothesis, critics want to continually argue about why my null hypothesis should not be rejected by false. And my advice is don't ever let them do that. It's debatable whether the Globers understand the fallacy of their arguments, but they clearly don't understand how a null hypothesis negates their fallacious arguments. The bottom line here is that you should perform theodolite measurements only to satisfy your own scientific curiosity, because critics are going to claim that refraction explains why your theodolite tells you the Earth is flat when it's really round. So if they don't like my null
And real,
hypothesis,
real quick before we move
go
on,
ahead.
I wanted to say about the refraction corrections and the gravitational anomalies. What he's referring to specifically, right? For those of you who don't know, the geoid model is a gravitational model that intersects with what they call the ellipsoid model. And when they went to take measurements based off of their ellipsoid model that were more precise, they found that they had to make additional corrections. And the excuse that they gave was that at their location, when they're taking zenith measurements of stars, when they drop a plug bob to make sure that their device is level, that it's actually being swung not towards the center of the ball like they think that they think happens, that they think makes level relative to the center of the ball. They say it's going off center to it, and they have to correct additionally to the difference of that, and that's a gravitational correction. So when you go to the WGS 80 anything or any of the WGS models, and you look at that ball and like it looks like a heat map, that's a heat map of gravitational fluctuations that cause these theodolites to have to deviate, you know. So they're saying that like you think that it's level here, but actually you need to maintain a perpendicular relationship to the gravitational geometry of Earth. And that's why your theodolite's off. So to maintain that relationship, you just gotta tilt that bad boy a little bit and you're good to go. So that's what they're like. They're invoking unlimited. Imagine we took a measurement and we were like, oh, well, you know why it doesn't look flat, dude? Because you have to tilt your theodolite. They would be instantly suspicious. Like, what?
You know, how not flat does it look? Well, guess what? That's how much you have to tilt it. That every time it's crazy.
And
It works.
they have unlimited tilts and corrections, and they have a math formula specifically that pre-assumes and incorporates the radius value in it to turn any observation into a planar observation due to weather. So even if you get a more expensive theodolite, that'll account for gravitational anomalies and offset your plug bob and do all that, right? Even if you do all that, they're still going to be like, oh, well, you know what? The atmosphere, dude. It's unpredictable. I'd like to see all your lapse rate every 6 inches to the whole way there. 10 miles
Yeah, and that's
vertical,
where
10
I quit
miles
arguing
out.
with them after that, when they
Yeah.
just started saying atmosphere. And then go and look into the atmosphere and how simple that is to try to, determine what's going on in between this 10 miles right here. They can't do it very well. With the
No.
greatest technology they have, they're
Nope.
horrible at it. So yeah, I was like, okay, I'm done arguing with people over the atmosphere because
Yeah.
I'm sorry, the atmosphere isn't going to give you 816 feet over the 40
Oh.
miles here it takes to look at the Chicago skyline. I'm looking at it. It's backlit with the sun. You can't tell me. No, I'm sorry. It happens every year too. It's not like this magic refraction just happened so on this one day. I came on a day where it lined up perfectly with these two lighthouses. And it was just happenstance. I was just out there, and all of a sudden there's like 50 photographers out there when I'm getting ready to walk away and leave. And they're like, oh, no, you can't leave. The sun's getting ready to set right behind Chicago. Yeah, I just went out there because the humidity was low enough. I'd been waiting for the humidity to drop to get good pictures out there. And yeah, I got real lucky. But no,
Nice.
it happens every year on the exact same day. It's not a magical refraction thing. It just happens once in a while. There was like 50 guys there with cameras, so it's a common occurrence.
Yep. Oh yeah, dude. Our boy Jim, shout out to Jim, peace be upon him. He went out there all the time for like 4 months in a row and took pictures of it almost every day. There would be like a couple days where it wouldn't, but like almost every day of the week he had a bunch of videos on YouTube about it. But yeah, real quick before we move on, the refraction equation, you'll notice that, there's a radius in there that can extend to infinity, but there's no distance or variable in there that tells you where a distance is too far and they've reached their maximum limit of like, this breaks
There
the
you go.
equation. And that's extremely important because if you're using that to verify your observations and it's not falsifiable, then what you're doing isn't scientific. If you have no threshold, if you have no personal distance, like, because it's not included, you have to make the personal decision of like how far is too far for you. So if you can't do that, you're willing to just refract everything to in perpetuity, then then it's definitely a globe for you. Then I see why. If you want to be unscientific about it. But yeah, anyway, please continue, Dr. Mike. Unless did you want to add something real quick, Shane?
Yeah, I was going to bring up Ruhif, but you kind of nailed it without mentioning his name, right? The people
Oh,
who
yeah.
will argue 7/6R below 100 meters of the Earth's surface is literally infinite refraction. So if you say anything is too far, he will, with a straight face, say nothing is too far. You can almost see your own ass, right? That's literally his debate position, is that he'll argue refraction infinitum. So I think that's just a good representation of most of the globers that will be refuting it, right? Well, we can refract infinitely, so there. And it's like, yeah, okay, moving on.
Yep. Yeah, that's why this is so good, though, because we're gonna use it against him.
Yep, and they don't want to refute their own null hypothesis. They want to criticize yours, but that's not the way the whole null hypothesis work. If they don't like my null hypothesis, they are free to reverse H1 and H is not, or develop their own and then try to demonstrate the falsity of their own null hypothesis that the Earth is not a globe. So let's do that for them. How would they go about falsifying the Earth is not a globe null hypothesis? Well, photos are not very convincing when compared against precise theodolite measurements. And equally unconvincing are the many correction factors they need to explain why measurements demonstrate their null hypothesis is true rather than false. They would need to modify their hypothesis to claim the Earth measures flat because light is bendy. Atmospheric refraction makes the Earth measure flat. And if you refute their null hypothesis with a much more expensive theodolite, then they will need to claim that local gravitational anomalies cause ground level to be skewed, thereby making the Earth measure flat, and or because atmospheric disturbances cause little ripples, and or because mirages cause reflections. Their arguments for why the Earth measures flat are inconsistent depending on the method used to demonstrate their null hypothesis is true rather than false. So after all that complexity they want to introduce, if all else fails, they will just claim your diagrams are too complex for them to understand, which is why I annotated mine in red. So if anyone's convinced by their attempts to dismiss the fact, I meant to say, is anyone convinced their attempts to dismiss the fact that undiddled measurements indicate the Earth is flat? When you look at things from the perspective of what they need to claim to falsify their null hypothesis, it helps to highlight the absurdity of their arguments. So I asked myself, is there an easy way to overcome all those absurd arguments? And the answer is yes, there is. And this is it. We can do better. I'm going to ask the Globers to try to understand the concepts illustrated by this simple diagram. Both flat and globe Earth advocates agree that the position of stars in the sky is precisely known. And we don't agree on refraction, of course, but we agree that the actual position is precisely known. So let's assume for a moment that atmospheric refraction is flawed due to commingling it with the curvature of the Earth and probably many other reasons. If that's true, then turning off that so-called correction permit an observer on the flat Earth and an observer on a distant mountain peak measure the same elevation along the same straight line of sight. So now let's assume that I'm observing Pikes Peak, occluding stars from my house. Before I say anything else, since the flat Earth elevation of Pikes Peak is 2 degrees 31 arc minutes from my sunroom, then a flat Earth observer on top of Pikes Peak should measure the star at that same 2 degrees 31 arc minutes when it vanishes from my view. The only difference would be that I will see the star at its initial bearing from my house, and the peak viewers will see the star at its final bearing from my house. And for those who may still not be grasping that concept, I'm about to perform an experiment where I determine whether a mountain peak occludes a star at the exact elevation predicted by flat Earth trigonometry. I set up my Oh, go ahead.
So at this point, I have a little question, right? I think Glober's brought this up, and I think it's a valid question. So from your position, right, on the right-hand side is your house, right, with the little stick figure. On top of the mountain is Pike, right? And then on top of the mountain is the observatory. Between the mountain and the observer, is there like 50.7 kilometers?
Exactly, yes.
So then shouldn't the star declination change by the, are we allotting for 69 miles per degree between them, which is like what, 0.45 degrees or something, 27 arc minutes between those two?
So they are, we are not. We're saying it's a straight line view from us to the star, not impacted in any significant way by refraction, not impacted in any significant way by bendy light. And because we believe there is no flat Earth, that means when our line of sight reaches the peak, it should extend into what that same line of sight that an observer on the peak would observe that same star. And how do we know whether that happened or not? Because if that happened, then the instant that star is occluded by the peak, I will cease to see it from my sunroom, and the observer on the peak will see it just dip slightly below 2 degrees 31 arc minutes. And I want to make it really clear, I'm talking about an uncorrected observation of that star. In other words, he's got to know the real position of that star in the sky, not that fake position that's skewed by alleged atmospheric refraction. And
Real
that's
quick,
really
do they record data that close? to the horizon? Can you get data of where a star should be when it's that close to the horizon? I know they don't keep a lot of data under, what is it, 18 degrees, I think, because of atmospheric seeing, they call it.
Yeah, and actually, I'm going to proceed to show you exactly how to do this experiment.
Okay.
And you don't even need a mountain. You just need something tall and far away from you where you can see the top of it, and it's wide enough that enough stars will be occluded by it that you can see the exact instant that star disappears behind the mountain, the building, the statue, whatever.
Nice.
And for those who may not already be aware, the globe on the right illustrates why an observer on the ground views a mountain peak from the initial bearing. And this is, of course, from the globe Earth point of view, whereas an observer on the peak views a star from the final bearing. That's because bearings change as you move with longitude. And those bearing changes are far more intuitive and obvious when you're looking at a flat Earth map than they are in this globe Earth projection. But since bearings are relative to north, and that's why I picked this particular one, it's easier to visualize. Oh yeah, those compass points are all pointing to where they perceive north to be. You can see they're all pointing in different directions, and that's why the bearing is changing. And since bearings are relative to north and north changes as you traverse those longitude lines, your bearings relative to north also change. And for both flat and globe Earth, bearing corresponds to the azimuth of the star being observed. And my man Shame has come up with some really good tutorials for those who may not understand why both flat and globe Earth use the same coordinate system. And I recommend starting with his link on the bottom left for anyone who needs tutorials to understand why globe and flat Earth both use the same coordinate system. This is the point where it's wise to defeat the globers using their own tools. There's many advantages to that. Probably the biggest advantage is it puts them into the position of having to argue their own tools are no good in order to refute your results. And some of them have already done that, ironically. Stellarium is a very popular globe Earth astronomy tool that's a free application for my Chromebook. And with proper configuration, Stellarium shows the elevation of a star when the peak occludes it at my location. Default, Stellarium uses atmospheric refraction, so it's important to click the atmosphere icon to disable that correction. And that's important because falsifying the null hypothesis depends on real measurements rather than measurements that have already been fudged due to the alleged correction for refraction. So you want to know where Stellarium says the star really is rather than where it appears to be. And it's also important to set the location from which Stellarium views the sky to mountain top, not from the mountain top, not your location. That's the mistake Rue made when he sent his team of so-called professional surveyors out here to measure the elevation from my house. No, that only tells you where it appears to be from my house after they've worked their globe Earth magic on it. So Stellarium, when you set Stellarium to view the sky from the mountain peak, because it assumes you are on a globe and it modifies the angle accordingly, that's why it will allow you to easily determine whether the uncompensated Stellarium elevation for the star is in line with your flat Earth view of the peak. And I think Piso, as I recall, Piso's explanation that was much better than what I just told you. But basically, Stellarium knows where that star really is, not where it appears to be. And you
Yeah, that's
want
the
to know,
kicker.
yep, you want to know where Stellarium says that star really is from the mountaintop, because what you're trying to accomplish here, you already know the flat Earth calculations show that from you to that mountaintop, the elevation is 2 degrees 31 arcminutes. What you now want to see is, does Stellarium show you that the real position of that star is at an elevation of 2 degrees 31 minutes from the mountaintop?
Yeah, it says for astronomical observations made at low altitudes, like considering navigation. If you're using it for navigation, they say to use nothing lower than 10 degrees because of the reliability of the observation, and the value actually go as high as 32 degrees. So if you're doing it for astronomical purposes, they say you start at about 30 degrees. But if you're doing it, you're out on the water and you're trying to find your way, that you never take a measurement below 10 degrees because that's where all the interference and the crazy stuff happens. Maybe if we could get closer to the mountain and make it a little bit higher of an angle, that might help a little bit. I'm just thinking like a glober, like what could I say to make it, what could my argument be? And with it being that low to the horizon, I could see them throwing some nonsense out there.
Yep, and I really appreciate that comment, and I want to be really clear. I'm not saying that corrections for refraction are a totally bogus concept. What I'm saying is the way they've implemented it is totally bogus. And this simple technique eliminates all those arguments, because it doesn't matter where an observer on the peak observes the star appear to be. What matters is where Stellarium says it actually is, independent of what the atmosphere is doing to it. And the reason for that is, as soon as the star dips below at elevation where it really is, it should immediately disappear from your location if the flat Earth calculations of that elevation were correct. So that's what we're going to test. And before I go on, this is a trigger warning. The remainder of this presentation may cause cognitive dissonance to those who believe the Earth is a globe. And that's because they're going to be faced with the dilemma that their own globe Earth tools clearly indicate the Earth is flat. And we
So I
may
think
have to discuss that in a Q&A session afterward a little bit if any of you are still having trouble with that.
it could be possible that all stars have flat Earth elevation angles, therefore occulted by atmospheric corrections in Stellarium. Is that a valid position now?
Wow, I'm gonna have to think about that one. So, although the Globers are already arguing that Stellarium is an inadequate tool, please follow and this may seem a little bit like a repeat, but it's not quite a repeat, and you'll see why. Please follow these instructions to easily
Stellarium is pretty
configure.
accurate.
Say that again.
Oh,
Stellarium
yeah.
is pretty accurate. I
Yeah,
measured
Very-
against
yeah.
it for months, and it
Well,
was always right on.
They're in this weird position where now it's not their friend, so it's not accurate for this, but it's accurate for everything else. So that's kind of where we're at with it.
Yeah, I went and
and-
tested it because they were using it back in the day so much. So I used it in the U.S. Naval Observatory, which are pretty much the exact same thing, and then I measured for like 8 months, measured the sun exactly where it was with a sextant, and it was always right. There were 2 times it was off 2 degrees, but it was because of something in the atmosphere. You know, you could tell the day before it was right here, this day it was supposed to be right here, and the next day it was right on. But that one day in the afternoon, it was off by like 2 degrees. It happened 2 different times.
And personally, I am blown away by how accurate Stellarium is when you use this particular technique. So after you turn off atmospheric correction and you set Stellarium's location to latitude and longitude of the mountain peak you're observing, the next thing to do is turn on the Telrad bullseye and center it on the final bearing at your expected flat Earth elevation, whatever you calculated that elevation would be on a flat Earth. And Stellarium also has many other good reticules and gladic reticules, including some custom ones if you don't like Telrad. But I'm just using Telrad because that makes it pretty easy. So at this point, Stellarium is now properly configured to identify every star the peak occludes. So you'll see that star disappear, and it's right in the bullseye on Stellarium at that point. So for my particular viewing environment, because I'm way out in the country where I have great astronomical viewing conditions, but I'm looking toward a big city, and so I've got some light pollution. So for my viewing environment, I also found it real convenient to limit the magnitude to 7.6 or lower. So I'm seeing bright stars, and I'm having no trouble telling the exact point where they disappear. And that prevents Stellarium from showing me the identity stars that are too faint for me to easily see with my toy telescope. A lot of people claim the C-Star S50 is a toy. It's way more than adequate to do this little experiment.
Well, that's amazing to see the building like that. Because I've been up in that building. It's not a huge building by any means. That little observatory. It's 1 story. It's not big at all. That's amazing. You can get it into focus like that. That's awesome.
I agree. When I first saw that building through the 8300 Theodolite, I was amazed at how easy it was to see that building. And through the telescope, it's even a little better. So despite what Globers, and here's their dilemma, despite what Globers claim are Stellarium's gross inadequacies, as long as their bogus atmospheric corrections are turned off, it somehow manages every time to show stars at the expected flat Earth elevation at the moment the peak includes those stars. Is my noise canceling still working good? Because my dogs were barking really loud just as I was saying that.
You're doing great.
Yeah,
good.
Barely heard anything.
It sounded like what you just described is Shane just stole Stellarium. It just uses negative coordinates to plot where the stars go out from your field of vision. Is that what just happened? Do we own Stellarium now, Shane?
Dude, like Zach said, dude, it's super accurate. I've had 0 problems with it when I use it to try and make observations or make correlative comparisons on other observations. I've never found it to be lacking. Now, you can turn off that atmosphere condition, which I do all the time. I never even thought about it, right? Because I just said I want the actual observations. So talking about what he's thinking, so literally they're all just flat Earth observation levels, and then they occlude it to the refraction scale, I would argue. And then that gives you your atmospheric corrections, and that gives you where the stars, versus actual and apparent, right?
And I spent a lot of time playing with Shane's model, and I am very, very impressed. And it really helped me understand things from the flat Earth point of view. So when I set about to come up with this method for eliminating all the objections, that made it a whole lot easier for me to logically think through the steps I needed to perform to pull this off. All right, now this is, as you should be seeing an actual star being occluded by the Pikes Peak on the left. And this is the video taken by my telescope that I then converted into a GIF. This time-lapse video was 2 minutes of viewing the Pikes Peak Visitor Center from 50.7 kilometers away, my sunroom. And right in the middle of this, you'll see that a jet flew from south to north. It was probably on its way to Denver about midway through the video, but this was my first relatively good shot of a mountain peak, including a star. So that's why I'm giving you to this. This was my first successful, really good capture of that happening. And the photo on the right is the video frame 1 second before Pikes Peak Visitor Center included that star. And that star was 39 Aquarii, and that occurred at 25 seconds after 6:27 p.m. Mountain Standard Time, January 31st this year. White rectangle on the left side of the peak is the lights in the observation room of the video center. And of course, the stars on the right side. And there's a light dusting of snow on the peak that's visible due to the starlight from the clear sky above the peak. So when you look pretty closely at those photos, you can see all of that. And then this is what Stellarium showed. The light gray circle is the Stellarium view of a 15 arc-minute radius around the approximate midpoint of the ground level of the Pikes Peak Visitor Center. That was about as closely as I could get it centered. The dotted red line is the expected 2 degrees 31 arc minutes elevation of stars that are being occluded by the visitor center. So it was about 2 arc minutes, which is 8 clock seconds higher than expected. And there could be a lot of reasons for that. I was just willing to accept that plus or minus 2 arc minute uncertainty. That was close enough to prove the point. And it removes all the doubt about atmospheric refraction. It removes all doubt about gravitational anomalies. Just all the crap they want to throw at you about why your measurements are inaccurate. It throws on how accurate was Stellarium, and oh, what do you know? Stellarium agrees exactly with flat Earth calculations. So 15 arc seconds was because the Visitor Center had not yet occluded the star at that point. Another 15 arc seconds was due to the height of the Visitor Center above the ground. Thus, the actual deviation from the expected measurement was about 1.5 arc minute, which is 6 clock seconds. There's probably another clock second in there because, like I said, I set to be able to capture these stars easily. I set my C-Star camera up for 1 minute exposure. So it could be capturing these stars a minute late because it takes that long for it to register on the sensor inside the telescope. And this is a summary of the measurements according to Stellarium. At a bearing of 29 degrees, 30 arc minutes from the top of Pikes Peak, Stellarium says the occlusion elevation of several dozen stars was 2 degrees, 46 plus or minus 2 arc minutes with correction for atmospheric refraction on, and 2 degrees, 31 plus or minus 2 arc minutes without correction. For my sunroom, Stellarium says the occlusion elevation of those stars was 2 degrees, 19 plus or minus 2 arc minutes with correction for atmospheric refraction, and 2 degrees, 4 plus or minus 2 arc minutes without correction. And that, by the way, is exactly what Rue's professional surveying team found. What do you know? Thanks, Rue. You confirm this data. For the uncorrected elevation. Yep. Thanks a lot. We really appreciate that. For the uncorrected elevation of those stars, when viewed from the top of Pikes Peak, dark red values are a 3 sigma match to the flat Earth calculated values, thereby failing to reject null hypothesis that Earth is not a globe. In other words, the globe Earth null hypothesis that Earth is not a globe is true. And think about that. Their tools disprove their hypothesis. Sorry, disprove is too. I've said this before. It's too strong a word to say you're disproving it. What you're demonstrating is that their null hypothesis is false. Therefore, their hypothesis is probably wrong to a 3 sigma level of certainty. And
Lack of evidence
my
versus evidence to the contrary sort of thing.
Which one is 3 sigmas? Is that 97.999 or is that 99.999?
99.7.
99.7.
Yep, that's the 99.7. So
Gotcha.
that's a level of in dissertation work they call that a level of confidence. That's a level of confidence that is in the neighborhood of some of the best doctoral dissertations out there.
So
and
you're saying your
the
data was corroborated with statistical significance of 99.97? Some of the highest
Exactly.
academic doctoral theses out there have been built upon this. Nice. Cool. So we own Stellarium
Exactly.
now. Thanks, lads.
Yep, and you know the exact steps that I feel like this is a Spock's brain moment where Dr. McCoy is saying this is so simple a child could do it. You've got the exact steps it takes to configure Stellarium. Makes this so simple your kindergartner might be able to pull this off. I remember when my daughter, actually she was pre-kindergarten when she was using my Commodore Amiga to create art. This is my daughter who has a PhD in mathematics now. Excuse me, she has a PhD in education with an emphasis of online mathematics. But like I probably told you before, I take a little bit of credit for her getting her PhD because her major as her bachelor's degree was mathematics. And she got so excited when she realized I could no longer answer her math questions that
She's going to
excited
teach
her
you
to go
now.
on.
Yeah.
She was thinking, yeah, I just finally exceeded my dad. And that motivated her to keep going until she got her PhD in education, specializing in online mathematics.
That is awesome, man.
We'll allow it. You get credit.
So my plus or minus 2 arc minutes of uncertainty, it may be due to real atmospheric refraction at the current temperature and pressure. It may be due to other things. Is just an uncertainty, and we always have to accept a little uncertainty. What G.G. Bennett either didn't admit or may not have realized is that the large corrections by his atmospheric refraction equation, what that is really doing is transforming Earth measurements into the illusion of a globe Earth.
It's been our position for years. I'm glad that you finally found the source of it and just put it on display for everyone like this and falsified it.
Yeah.
Using
Hey,
the
Alan,
celestial theodolite. What's up?
You know that optics graph we make from looking at the stars 69 miles per degree on that spreadsheet that ends up being the logarithmic curve as it approaches infinity, right?
Mm-hmm.
That's the exact inverse of the refraction chart that we just looked at. Like if you were to put
No
those two
way.
together, they would be perfectly symmetrical. Yeah.
Yo, you got to make a
Just-
thing for
just-
that. That's insane.
Something to point out. Yep.
Yeah, that's dude.
So what he's saying is exactly backed up by if you were to take those two graphs and just put them together, yeah.
Dang.
You can tell by your face you got it.
That's insane, dude. We had, oh man. Do we see in Globe Vision? Yep.
Yep.
Sure do, buddy.
Yep. I haven't had time to do this, but I think it was Alan who suggested I put error bars on my measurements. So it would be great if you could do that and put error bars on it. I just took a look at that correction and I instantly realized when I saw it, oh, these guys are transforming flat Earth into globe Earth, and either they're maliciously doing it on purpose or they're so dumb they didn't realize that's what they were doing.
I like those two positions. I'll take A for most and B for the really obstinate people. I do think a lot of people just apply it like without thinking what they're doing, right? And just being like, well, this is what I have to do. I learned it in class. These are the steps. This is the part before they're not even doing, oh, well, I got to correct my flat earth for globe real quick before I output. And there we go. There's my answer.
Yep. And I have to admit, I was like that. And if you read my first book, Ramblings of an Old Man About Prime Number 17, that I published in 2020, you'll realize that was where I began a big part of my transformation of beginning to question things I thought I knew. And then later that year, that's when I wrote Ramblings of an Old Man About the Scientific Method. And you can see there, I was beginning to question a lot more and realizing we've been told a lot of stuff that's just false. And then by the time 2023, I got to the luminiferous ether, and that started out Ramblings of an Old Man About the luminiferous ether. I spent about a year and a half revising it, and that's why it didn't come out till 2023, to make it less rambling and more focused on luminiferous ether. And at the time I published that, I hadn't yet calibrated it the way I presented in Ether Roundtable 63 to a 6 sigma level of certainty that all of the fundamental constants of physics are demonstrably produced by luminiferous ether. So you can see, if anybody who wants to like delve into my journey, you could read those books for their amusement. And I think I've got them all configured now. So you can get them free if you have Kindle Unlimited. And I'll have to warn you, took me years to figure out how to trick Kindle Unlimited into presenting equations properly. So only the luminiferous ether does a really good job of producing equations. The rest, you get a peg of a snapshot of the equation, and it's readable. You can't like reverse. You can't, if you like dark mode, you can't get white equations on a dark background. You have to settle for the black on white. So it took me a while to figure out how to outsmart Kindle. It's almost like Kindle Direct Publishing didn't want people publishing equations. I don't know why they might feel that way. But anyway, I'll move on now and stop pontificating. To summarize those measurements we just discussed, if the Earth is a globe and Pikes Peak tilts west and my telescope tilts east, with atmospheric correction on, Stellarium adds 15 arc minutes to its uncorrected 2 degrees 31 arc minutes elevation for the star, and thereby Stellarium produces an atmospheric lift to 2 degrees 46 arc minutes for an observer on the peak at the moment this peak occludes the star. At that same moment in time, Stellarium adds 15 arc minutes to its uncorrected 2 degrees 4 arc minutes elevation for the star at my location, thereby produce an atmospheric lift to 2 degrees 19 arc minutes from my location at the moment the peak occludes the star. And then let me see. This is if the Earth is flat, and the uncorrected peak elevation of the star and my uncorrected elevation of the star are identical. And within the state of accuracy, of what celestial or terrestrial theodolites actually measure. In other words, or should measure at least, with an atmospheric correction of the Earth, measures flat.
That's genius.
Yeah, so what occurred to me, perhaps Pike Peak is just an outlier, so let's move on to a different peak. And if you were looking at the regional draft of this that I sent to Ellen, I was having cloudy days. I couldn't make those measurements. So I put in that original draft what I predicted those measurements would be. And then this is where those calculations came from, of what I predicted the measurements would be. And trigonometry and theodolite measurements again confirm that the flat Earth elevation of Blodgett Peak is 1 degree 16 arc minutes from my sunroom. Maybe that's just a fluke, but that's why I developed this celestial theodolite technique because it takes all the uncertainties out of these measurements, and you just look for the star to disappear behind the peak,
Yeah, and to be
and
clear,
you can.
yeah, can
Go
I hop
ahead.
in real quick? Yeah, so to be clear,
You can.
the celestial theodolite, that mountaintop angle, right? The globe makes a different prediction. So if it matches what it matches in his sunroom, it's over. That means that mountain is actually there at that location at that angle, and it's not being refracted up, because if it was, then the star would be in a different position as well. And that's not what is happening. We're actually turning off refraction, right? The lowest amount of refraction, like not what that Bennett guy has incorporated, right, is what is being occulted here. And that's the significance of this. So like we got our regular theodolite on the right here, guy in the sunroom. Our celestial theodolite is that mountaintop blocking that sun, and a little lad on there with his theodolite looking out at the same exact angle that he has in his sunroom, and those angles matching, still aiming at that star.
Dude, I think the best part is that they can't invoke refraction for the star and not the mountain, and vice versa, right? Which is what
Right.
throws a wrench in the whole argument, because
Yep.
it's beautifully put forth.
Yep, and I appreciate Alan's comment, and that reminded me of it's even better. I've been forgetting to mention this, but I chose that particular method because it doesn't matter what a theodolite in your sunroom measures, because if the measurement is high, if the measurement is low, none of that matters because you carefully calculated what the angle should be when the star disappears. So the only thing that really matters is that at the exact moment that star disappears, whether it measures high, it measures low, what matters is where does Stellarium say the star actually was relative to the peak at that instant in time? And it's a match every time.
Yep. Yeah, that was to the point that Zach brought up earlier about elevation angles to the stars and like which ones are the preferred ones because there's too much refraction, etc. Yeah, that completely nullifies that. This is what the significance of that is. It shows that the application of that story is invalid.
It would just prove the globe to be wrong, so that's why it's invalid, right?
It would prove their application of refraction in asserting in it as the cause of why it's at that angle. Then yes, because it shows that it's actually there.
And the focus is back on the null hypothesis concept. So if their hypothesis is the Earth is a globe, meaning that their null hypothesis is the Earth is not a globe, what these straight line measurements show is, well, sorry guys, but we're refuting your argument that the Earth is not. Sorry, we're proving that your null hypothesis, the Earth is not a globe, is true, because we're confirming flat Earth line arguments show the star occluding exactly where it should disappear. So it's
Sorry, this is so significant because a lot of people will say, well, the Earth measures flat. They'll say the Earth measures a curve. We measure globe. Well, with respect to what is this measurement being made? We need some other reference. Like, we're told, like, as flat earthers, the mantra is usually don't look at the sky to tell the shape of the ground. For sure. But flat with respect to what? How much how much flat is it, right? So this is the external reference that's been given to us that we have, that's freely available, that we all use. So let's not throw it away here. You can use it to do this, and it verifies our position. It's flat with respect to the stars. These elevation angles only work on a flat Earth.
And what I realized is the more you think about this, better it gets. Because look at how complicated and unwieldy their math has to be able to come up with a null hypothesis you can't refute. Look how simple your math is to show they're wrong.
Yeah.
So a flat Earth observer on top of Pikes Peak should observe the star at, and I should really reword this. I want to get away from that that statement of the angle vanishes from the view of my sunroom. And what I want to get to is what it looks, the elevation it looks like from my sunroom is totally irrelevant. What really matters is what elevation, if you assume the Earth is flat, you calculate the elevation of the peak based on how far the observer is from the peak. You've got a angle that is so precise you can't duplicate that position more precisely using any method. And now you know if you're on the peak, what should the elevation, a straight line continuing from your view onto that star, what should that elevation be? And so what you're doing really is you're comparing where does Stellarium or your favorite astronomy tool, where does that tool say the star is at the moment it disappears from your view? Now compare that to the elevation flat Earth calculates it should be. And what do you know? They're the same every time, to within the accuracy of the observation. That depends on the accuracy, your timing, depends on a few factors, but you're getting it so close. It's unbelievable. I was like blown away about how well this idea worked. And you'll notice I didn't modify this particular diagram to help globers understand this concept. So they're going to be confused by all this, and you'll just have to help them through it.
See any red dotted lines, therefore I dismiss it. This is not evidence.
And they're going to do that. So if you want to add red dotted lines for them, go ahead. I spend so much time rescuing dogs and taking care of dogs. I really don't have time to appease their stupid arguments. And these measurements are for Blodgett Peak, trigonometry, and I'm going to change that to say trigonometry and
You showing the
where
same slide for me?
Stellarium say that again?
Are we showing a different slide?
You showing
Yeah,
Blodgett Peak?
I'm showing one that says should say Blodgett Peak.
I got it.
So it's got a new elevation, a new distance, a new elevation angle.
Yep.
So I'm sorry. Sometimes I get confused a little easily, but I want to change my terminology to say flat Earth trigonometry and astronomical tool elevation, uncorrected elevations confirm flat Earth elevation of Blodgett Peak is 1 degree 16 arc minutes from my sunroom. So that a flat Earth observer on top of Pikes Peak, I should change that terminology to an observer. I'm gonna have to rework this. I know you guys will understand what I'm saying here,
Yep.
but you know how easily confused
Yep.
globers are. They're even more confused than me. A 75-year-old man is confused.
It's so hard to tailor your statement to the dumbest glober, though. Let's bring it up to a higher common denominator, though. We'll just go forward with that.
Yep, but in any case, you'll notice I didn't modify this diagram to help globers, so they'll need help with that. And as before, I see this star at its initial bearing from my house, and peak viewers see the star from its final bearing from the peak. Again, I set my C star up for 1 second time lapse and 1 second exposures. The real key here is what Earth calculates the elevation should be compared to what the astronomical tool says the elevation should be at the instant that star disappears from your view. So here's my measurements. According to Stellarium, when that star disappeared, and Blodgett Peak is much narrower than Pikes Peak, so it's not nearly so many stars or direct hits. So it took me a while longer to collect this data. It had a final bearing, which is azimuth, of 262 degrees, 45 arc minutes from the top of Blodgett Peak. Stellarium says the occlusion elevation of numerous stars was 1 degree 36 plus or minus 1 arc minute with correction. Atmospheric refraction versus 1 degree 17 plus or minus 1 arc minute without correction. From my sunroom, Stellarium says the occlusion elevation of those stars was 1 degree 18 plus or minus 1 arc minutes with correction for atmospheric refraction, and 58 plus or minus 1 arc minutes without correction. So for the uncorrected elevation of those stars, when viewed from the top of Blodgett Peak, the dark red values are at least a 2.5 sigma match to the flat Earth calculated values. And that's about 90%, 90% confidence level, thereby failing to reject the globe Earth null hypothesis that the Earth is not a globe, a level of confidence of 2.5 sigma. In other words, the globe Earth null hypothesis that the Earth is not a globe is true. The Earth is not a globe according to this measurement to a 90% confidence level. So their hypothesis that the Earth is a globe is probably wrong to a 90% confidence level. So this your best example so far that I've come up with is Pikes Peak. You're over 99% confident using Pikes Peak. The Earth is not a globe; it's flat. And even 2.5 sigma is still in the neighborhood of what many doctoral dissertations are required to do. And to summarize again, these are the measurements we just discussed. From the globe Earth point of view, if the Earth is a globe, then Blodgett Peak tilts west and my telescope tilts east with atmospheric correction on. Stellarium adds 19 arc minutes to its uncorrected 1 degree 17 arc minute elevation of the star, thereby produces an atmospheric lift to 1 degree 36 arc minutes for an observer on the peak at the moment the peak occludes the star. At that same moment in time, Stellarium adds 20 arc minutes to its uncorrected 58 arc minute elevation of the star at my location, to thereby produce an atmospheric lift to 1 degree 18 arc minutes from my location at the moment the peak occludes the star. And at this point, the atmospheric corrections are no longer even a good match to the globe Earth predictions. So this, I say what Walter Scott penned: "Oh, what a tangled web we weave when first we practice to deceive." So maybe it was just an innocent mistake they made, or maybe they're intentionally trying to be deceptive. And then if the Earth is flat, it does make you wonder. And I don't want to impugn them. I think we're dealing with two camps. We're dealing with people who innocently believe everything they were told and never checked anything out for themselves. And then we're dealing with another group who knows better, and they're maliciously doing their best to confuse people about the truth. And I'm not going to accuse people of one or the other. I hope I'm giving everybody a lot of ammunition. So if the Earth is flat, then the uncorrected peak elevation of the star and my uncorrected elevation of the star are within arc minute of each other, and all of those values are within my margin of uncertainty. So like Pikes Peak with atmospheric correction off, Blodgett Peak is consistent with flat Earth. And as before, with atmospheric correction on, flat Earth magically maps onto a globe. And I want all, yeah, amazing, isn't it? And I want everybody to keep in mind this measurement technique is only 2 weeks old. I've only had the opportunity to measure these two peaks. I'm giving everybody the exact technique so any legitimate scientist can confirm my measurements and argue the little argument mistakes I may have made here and there. But I think any reputable scientist can easily outperform my observations over the last 2 weeks.
Can I make a comment on that?
Yes, ma'am.
If Ruhif does get someone to go measure and confirm your measurements, make sure that he does it at night. Because there are papers that suggest that the refraction can be changed throughout the day, or that things can be shorter during the daytime. And I wish I would have known this whenever I did my measurements, but yeah, make sure that they take that into account. And if the mountain is actually occulting the star, then that shows that rather than them being refracted up at night, they'd have to be being refracted down during the day, which could explain some of their measurements with why things are shorter if they're constantly doing daytime readings. So I just wanted to throw that out there, and I can try to post this paper in the chat or something like that. I do have the name of it right here. It's called Estimation of Temporal Variations in Path Average Atmospheric Refractive Index Gradient from Time-Lapsed Imagery by Dr. Sanitization. And there is one more paper on this, and it's called Image Shift Due to Atmospheric Refraction Predicted by Numerical Weather Modeling and Machine Learning by Dr. Al Yunus. So these are two papers that can confirm that things can get shorter during the day, explaining potentially some of their readings. But if they do go and confirm your readings, make sure that they do it during the same time that you did.
And I think all of your points are well taken. And atmospheric refraction, I'm sure, is real. Atmospheric distortion is real. I've seen the little ripples looking through a telescope. But and in my opinion, this is exactly why you don't want to confirm your hypothesis using theodolite measurements. Instead, you want to refute their null hypothesis by showing that you guarantee refraction is not a factor when you calculate what the flat Earth elevation should be and find out at the
Exactly.
exact moment the star
And so
disappears.
right. I was just going
Oh,
to
go
say that
ahead.
yours is not refraction, though, because if the mountain was actually occulted, if the mountain was actually occulting the star, that kind of disproves that whole thing, right? Like, it can't be that things are just being refracted up if it's actually occulting light. So that was kind of my point.
Exactly. I started out with this by saying I had been documenting this in what might have turned into a presentation as I was going along, and then I realized, by golly, I think I might be onto something, and so I sent it to Alan and I said, I think I may have discovered a clever way to bypass all of this nonsense. What do you think? And he started distributing it. So I think I took that as, yep, that's a clever way to get around all of their
Yeah,
arguments.
dude. Yeah, it was pretty insane.
Yeah, genius. Well done.
So I don't know if
Yeah,
people know who
you're right.
Taylor.
Where did you have the idea? Do you remember?
Yeah, that's awesome.
So like I said, Taylor inspired all of this. I got the theodolite, and it's when and maybe my theodolite was wrong, but I also have an astrolabe, and it's pretty. You can't read an astrolabe as accurately as you can read a theodolite. It tells you whether you're in the ballpark or not. And I was in the ballpark of the right model measurements, even with astrolabe. and it was pretty much a toy astrolabe. It's not one of those expensive, really accurate astrolabes, but I can tell a half a degree of difference on it pretty easily. And so color inspired me, and when I slowly turned the knob of that 8300, because you have to turn that knob really slowly to bring the crosshairs up to the elevation of the peak. And I did that, and because the degree and vernier arc minute measurement are on the side, I had to go around the side to see where did it end up. And that was the moment that really began to make me say, it seems like Flurfs are onto something. and and that's when after that I started digging into all the atmospheric corrections. And no sooner than did I look at G.G. Bennett's graph than I realized, oh, he's just compensating and he's transforming flat Earth measurements into globe Earth measurements. That's yeah, and I'm not saying there's no atmospheric correction in there, but most of his equation is transforming flat Earth into globe Earth. I think people are going to have to really work on valid atmospheric corrections because his are not valid. But that's my hypothesis. I'm not going to bother to prove that hypothesis, because I think celestial theodolite is even better. With that, you can just totally ignore those minute. I'm sure the refraction and distortions are all real, but they're so minor compared to the actual measurement, you can just ignore them.
Negligible.
And they amount to less than plus or minus 2 arc minutes. That's close enough to refute the globe Earth hypothesis, because they need way more correction than that to turn flat Earth measurements into globe Earth. And it's just not there.
Excellent.
So on some of the earlier drafts, I had some conclusions, but there's some valid criticism. It's not really conclusions. I'm going to change this to the biggest takeaways, and the biggest takeaways of all this is that uncorrected raw measurements are consistent with standard trigonometry on a flat Earth. And the other big takeaway is the atmospheric corrections applied by Stellarium and professional surveyors are consistent with the G.G. Bennett equation. And their wizardry magically transform flat Earth measurements into the illusion of a globe Earth. And with that, I'll ask, are there any questions? And we can discuss anything you want, anything more you want. I'll answer as many questions and listen to all you have to say.
Nice. That was excellent. Thank you, Dr. Mike.
My pleasure.
Yeah, very well done. Thank you.
Put a link in the chat to join our Discord. If anyone has any questions and would like to come on live and ask them, you don't have to come on camera, but that would be cool if you did. But you can just come on and ask on voice, or if you have any in the chat, just type them out and we'll go over them.
I didn't know that
Cooler
Taylor
if
was the
you did.
inspiration. You'd be cooler if you did, for sure. Not required, lightly encouraged, maybe hazed a little bit if you don't. Just kidding. No. Taylor, I didn't know Taylor was the inspiration for this theodolite. So the first celestial theodolite use. I had no idea. I mean, I know she's cool, but I didn't know she
Not
was the
that
actual
cool, bro.
inspiration.
And I don't want to put too much of a burden on Taylor and give her too high standard to live up to. And I want to give everybody here credit, because you've all helped me understand your position and figure out the ways to defeat the insane arguments against what you believe.
Right? I think we welcomed you because you were bucking the mainstream. You were like, I'm not getting the whole story. The government lies. And that united us in the first place, right? The bucking of mainstream, just, all right, well, let's figure it out for ourselves. And mostly when everyone does that independently, they all end up at the same conclusions, which is weird, right? So conspiracy theorists are a bunch of independent truthers who all arrived at the same independent conclusions. I don't know.
And when Alan first invited me to Discord, I didn't even realize you guys were flat earthers.
We never
I
mentioned it.
well, it took me a while to figure it out, but what I immediately noticed is you were all questioning the lies mainstream science was telling you, and I had already figured out those lies, some of those lies. And the other thing I noticed about you immediately, you guys were all applying the scientific method to the best of your ability. So I felt like immediate bond. Here's a bunch of people who realize the science is wrong and they're trying to apply the scientific method to refute that wrong science. Forgive me, Taylor, if I put you on too high a pedestal.
Oh, you surpassed it.
No, we're so thankful to have you joined Ether Cause, man. It's been great. You've been so supportive with the null hypothesis and other stuff. So it's been awesome, man. I'm glad that
Yeah,
you found a like-minded community.
I'd hate to ask for more, but I'm gonna real quick. You know, our buddy Cassander, I think you guys are working together on some stuff. What do you think the odds are of you bringing the celestial theodolite argument to his attention?
I can bring it to him. I've found, I think because of the way Cass likes to work and the way I have to work because of the dog rescue, it's making it hard for us to collaborate, and we've still got to work out how to do that. And I'll propose this to him and ask him if he's got any good suggestions for how we could pull that off.
Perfect.
Um,
Perfect, because we don't like to push him, but I feel like if you pushed him, it'd be different. You know what I mean?
well, and I don't want to push him either. He's if my brother were still alive, Cass is about the age my brother would have been because he's 10 years older than me. And I'm beginning to become well acquainted with old age problems myself. People say two things: the more you study, the more you learn. The longer you can postpone cognitive decline. So I think that's one thing I have working in my favor because I overstudy everything. And the other thing I have working in my favor is people say having dogs prolongs your life because you are
Keeps
their
you young.
service human.
Yeah.
Yeah, they're not your service dog. You're their service human.
No,
And
there is no not getting up to let them out in the morning. There is none of that.
No.
You
yeah,
know the
exactly.
consequences of not letting them out in the morning. So, no, as soon as I heard you say that, man, that you rescue dogs and you have I was like, oh, I like this guy a lot. That's like my
Yeah.
dream. If I ever fell into like, a couple $1 million, I would buy 500 acres and turn it into a giant dog rescue. It would just be nothing but if your dog needs a home, bring it. We'll find a place for it. That's my dream. Yeah, I love dogs.
That's where
And
I got my
cats
dog.
and yeah,
Rhode Island Home
everyone.
Rescue, man. My sister does like fostering. She takes dogs from there all the time, which is how I got interested in how I got my dog. Just picked one up from one of the rescues, man. It's the best way to go.
Picked up a border collie from the streets. Respect.
Yeah, he was the only one for sure.
Yeah, we got a question or a
have
comment from the chat from our boy Pablo's dog. Shout
ahead.
out to him. So he says gauge. So he wants to know gauge capability of the celestial theodolite, repeatability and producibility, and statistics. Basic statistics would be nice to have on hand. He says.
So being a former precision measurement calibration guy, I agree with him. I don't happen to know what those statistics were, and I'm so beyond theodolites now because they are so easy to refute using valid and invalid arguments. And that's why I wanted to come up with this better method where refraction doesn't matter, the accuracy of your instrument doesn't matter, because those of especially globers who have not yet figured this out, it doesn't matter whether you're watching that peak from an accurate instrument or an inaccurate instrument, the one thing that matters is, can you see that star disappear? And if you can, you have a stopwatch in hand and you can find out the exact time that occurred. Okay, now go compare that with what the best astronomical tool you can find says was the elevation of that star at the exact instant it disappeared from your sight. And if that agrees with the flat Earth um, calculation, I'm sorry, but no matter how much you dislike that, that refuted your null hypothesis. It demonstrates that, yep, it appears the Earth is flat, whether you like it or not.
Well said, and,
Demonstrated.
and that is the crux of it. That is the power of the celestial theodolite, like showing that that is the actual position and that is therefore the actual angle. It's just they literally have to argue against Stellarium, guys. Like, do you know how awesome that is?
I like
They're
how
just
both the null hypotheses line up, like the one with ours with the proving Earth curve.
can't
minus
prove
the
what
alignments
shape
of
it
the star.
is, but what shape it
Yep.
isn't.
How does that nicely align up with this, right?
Dude,
Perfect,
it's
perfect,
perfect,
synonymous.
bro. Very complimentary,
And then
one would say.
you get the extra advantage benefit if they have to start arguing the validity of their own tools, which that relegates them to, oh, our pictures show the Earth is flat. Is the globe is round. And so because I've worked in satellites so long, and because while I was working, I had an extremely high security clearance. I was able to see the raw satellite data that goes through a processing center, gets scrubbed before it's released to the rest of you guys, and that's, you're seeing. Many of you have pointed out, oh, these are doctored photos, and you're right. They're doctored for security reasons because there's things you're not supposed to see, and I can't discuss any of that. But I have seen the photos from satellites. The Earth really does appear to be a globe. However, notice that the whole globe philosophy is based on refraction causing light to be bendy. Well, what does that do to light in space?
Are you
Who
saying
has
pictures?
studied that?
Are you saying
And
pictures from
moreover,
space?
moreover, and Cass will point out what we all know. Einstein's theories of relativity are bogus, but nevertheless, they do make some valid predictions. And whether valid or not, it argues that mass warps light. And then if you go look at my book, The Luminiferous Ether, well, actually, I make this case even in the scientific method. At the center of the Earth, whether the Earth is a globe or flat, it doesn't matter. At the center of the Earth is an 8.8 millimeter diameter black hole. And it's got to be warping the heck out of all the light that the ether is pushing into the center of the Earth. And then go look at my on table 63, where I show you to a 6 sigma level of confidence that that very same luminiferous ether easily explains every single fundamental constant of physics that NIST publishes to 9 digits or greater of accuracy. There's definitely, we are on top of a black hole. So we are on the verge of some amazing science if we follow up on all the things we know are bogus.
Yeah, absolutely. And I have a question if you're able to answer it about the satellite stuff that you were looking at. Were you looking at actual, like the full picture that's already been compiled, or were you looking at segmented strips of data that they say, because they say that, they take it in segments or whatever? Or were you on like a far away?
I've got a I'm under an extremely strict
Yeah.
non-disclosure agreement literally under penalty of death. But I will tell you everything I can, and what I can tell you is my organization was the switchboard. So we were the people who took the raw satellite data and routed it to the people who needed it without telling them where it came from.
Oh,
Man, that's so hilarious because there was that one paper that we came across where the
Wolf and
lads,
Pettit?
yeah, Wolf and Pettit, they got
Already
their raw data and it was already corrected. First order timing measurements of the speed of light were already corrected, and it's like, how did that happen? Oh yeah, there's an agency of people that do that beforehand and then give it to everyone else. Got it. Yeah, dude. And then we also found out the phase carrier and what was the other thing, Shane? Like
the actual
yeah, the thing that
GPS
most people
origin.
call raw data, it's not even raw data. So
Yeah, well, that's when you get to like pre-corrected ECEF coordinates where they give you to like the XY, but then they give you, well, the surface of Earth relative to the surface of Earth, and then that gets interpreted only via a spherical datum, so they relate it to the top of the WGS84 to give you uncorrected ECEF with, pre-corrected height that'll show you a curve.
Yep. In the intelligence community, what we at the various intelligence agencies called the raw data is unsanitized. And then it goes to a processing center where they scrub out everything they don't want the rest of you mere mortals to see.
What a connotation. Sanitization.
yeah.
Yep. And a
Gotta
little
clean the
bit to
truth
their
off of it.
yeah,
Yeah, right.
I'm gonna defend them a little bit because we do not want our enemies to know what we are able to see. We want them to always be guessing about how much do we know. And that's why we can't confirm or deny anything. It drives my wife crazy when she sees them talking about something on TV that I know the answer to, and I tell her, I'm sorry I can't talk about that, or I'm sorry I can't confirm or deny what they just claimed. It just drives her crazy because she knows I know, but I can't tell her. Um,
Can I ask you a question, Dr.
but
Mike?
yes, ma'am.
You can neither confirm nor deny the answer, Taylor.
I was just gonna ask. I was just interested in this, and I was looking into it about like private citizens putting up a satellite. And so theoretically, if you like purchased a satellite and then hired somebody to launch it or whatever, and you have like a camera on it, could you theoretically see what it looks like
Ooh,
without it being sanitized?
I'll take this one.
Go ahead.
So there was like unlimited Kickstarters and GoFundMe's of people doing exactly what you just said, trying to go fund their own satellite project to go launch their own things, and every single one of them, the ones that they actually, the ones that they actually try to follow through with, the ones that aren't just a scam, they find that the FCC ends up blocking them from launching anything or doing anything.
What?
Yeah, and the same thing, they do the same thing with weather balloons. There was, if Ira was here, we could get him to tell the story about how they were going to launch some weather balloon thing in Argentina, I think it was, or Brazil. And basically, because it was like, being publicized, it ended up getting shut down. And they found out that it was basically our government called their government, was like, don't let them do it or whatever. And they got their people that are in charge of their airspace stuff to, shut it down and restrict it and be weird about it.
And then, and an additional answer to your question is Elon Musk's of Starlink. Those are private satellites, and I'm a major fan of Elon Musk and everything he's doing, and I know that not all of you feel that same way. But I'll tell you why I'm such a big fan of him. I don't think I'm allowed necessarily to disclose how much launches were costing us, but I was working in the Office of Space Launch when Elon Musk was getting started, and we were helping him get SpaceX off the ground, literally. Um, The reason we were doing it, he was launching satellites for 3% of what the United Space Alliance was charging us to launch satellites. So in practical terms, what that means is we could launch 30 times as many satellites for the same cost. And he was actually doing that with his own satellites. And that's part of the reason he was doing it so cheap at the beginning when it was costing him more. But we actually got him to the point where he was saving us money and making a profit doing it.
Dude, that's
So
awesome.
do you
And
think
because,
that,
oh, go ahead.
no, it's
Huh?
okay. And I was just gonna ask you another question about satellites, but I was just wondering
You
like
can go
if
ahead.
you've ever heard of anybody doing that and having a camera on it themselves. And then another side note was I was at the observatory the other day and somebody brought up like private like space operations and the person that was running the telescope got like so angry and like heated and was like, no, we don't need any private organizations, like, and it was just crazy.
So
Well,
I don't know of anybody who's actually doing it, but it could theoretically be done. In some cases, like in his early days, Elon would lose his satellite because we were the switchboard. We'd give him the signal he lost, but we couldn't tell him how we got it.
that's insane, dude. So real quick on satellite orbits, I wanted to show you some circumpolar orbits and what they should look like on a globe versus what they look like over a flat Earth. Have you seen that yet?
So one of the things I am strictly prohibited from talking about is satellite orbits.
Okay, if I show you the orbits and you say nothing, but we go over it for the audience and you just nod along or turn your camera off for a second,
Don't even interact. We'll just show them. How's
we'll
that?
present the. Yeah, we don't want to get you in trouble.
That's the trick my wife is constantly trying to pull on me. And another trick she tries to pull on me is she discovered that my subconscious can talk to her while I'm asleep. And so she tries
That's
to talk to my
dangerous.
subconscious. It may be dangerous, but she didn't seem to realize I'm well trained to be aware of what my subconscious is doing and not answer her questions.
Oh, that's
Wow.
excellent. And you know they're always listening, right? You know that.
Or can you turn the screen
I
share
have
off for a second?
I've been under constant surveillance my whole life, so I'm just used to it. I don't even try to hide.
We got a screen share real quick. So can we do one?
Oh, do you ask me to turn off screen share?
Yeah, I wanted to show everyone who isn't you
Sorry about that.
the circumpolar stuff for the satellite orbits, because this is extremely important, because we actually added this to the null hypothesis here because it worked out so well for us. Let's see. 30. You guys see that? Okay, you guys should be seeing a globe with some pink lines on it.
Mm-hmm.
Okay, so we're all familiar with these longitude and latitude lines here. Now, what this pink line shows us is what an orbit would look like on a globe if this projection was, truly represented on a globe, where you could go around the north and come out from the bottom from the south and come up again, right? So here we're looking at what an orbit would look like going north to south, and then from south we're going back up to north. This is what it would look like. This is what it would look like on an equirectangular projection, and this is the one that they always show us that has the spirograph on it. So we're going to look at what these would look like on a different projection here. Now, because this latitude-longitude system, otherwise known as the geographic graticule, is invariant under transformation with some corrections applied to it, you can, this projection is just as valid as this one, is just as valid as this one. This line here will transform correctly when you apply the correct corrections to it.
Right.
So anyway,
we only drew it in one, and we just projected it to the other two.
Yeah,
This
we
is how
only
that works.
only drew it in one, and we ended up with this. So take a good look at this, because this is the only time you'll ever see what this would look like if you could come up from the bottom of the ball, go over across the top of it and come back down and then loop around the other side. This is what this would look like if this were their true orbits. This is what they show us.
North-south circumnavigation, right? That route, that's what that represents, which no one's ever seen, and they claim to have done all the time. But all the routes will look like this, as Alan's showing now.
Yep, and they're showing us the spirograph that we always see. So if you ever turn on the news and you see something about the ISS, they'll show you this nice spirograph here. Now, when you transform that, you get this. You get figure eights over the sky that never go, they don't make the corresponding straight lines that they would do if you're going up and coming around. What they're doing is they're going out, they're coming back, and they're just looping around. They're just doing figure eights in the sky. And Japan recently has like a mini circumpolar orbit thing now where they do this figure eight in a smaller area. They're never going around the ball and coming up. So we took a bunch of different orbits that are publicly available, and they all show the exact same thing when you transform them, none of them corresponding to what would the proper line look like on a globe when you transform it.
Yeah,
So
they
we
like
just-
to show you in an equal area projection like this right here, and like to show you, look at these north-south circumpolar, and like this couldn't be possible on a flat Earth. Then you're like, oh wait, well actually it's equally. Well, hold on, scratch my head. Now I'm confused, right? Because they're saying that it's not possible, but when you actually plot it, totally possible. The only thing that wouldn't be possible is the first one that we showed.
Yep.
You can actually track pico balloons too in some cases, like the radio balloons, and I've seen it actually do that too. And the pico balloons can stay up for a surprisingly long time. Like one of the videos I was watching, it was like at least 72 days. But they can last much longer than some people think. And that orientation was kind of how I saw it go. It started going up to the north and then came right back down. And I was like, is it gonna cross? No, it didn't. But yeah.
Yeah, they can even control those balloons too. They have electrostatic tethering, they call it. They'll have a big long line hanging off of the balloon. And, jet streams are going in different directions a lot of the times at different altitudes. So say it's blowing east to west and they want to, it blew it too far off course, they'll either raise it or lower it to hit another jet stream and blow it back to the west. Just by changing the electric charge on this long wire, it'll raise it or lower it down. Yeah, they've got it down to a science controlling these balloons now. It's pretty amazing.
All right, real quick, we'll just go over some. The balloon thing is fascinating because they can actually stay up even longer than that too. I forget the how long it was now, but I think it was like over 200 something days they can do it. And then they have hydrogen balloons that can go up to like 250,000 feet or something like that, something crazy. But anywho, finish up on circumpolar terrestrial navigation, so airplanes and such, where they say that they've done these routes, and it's kind of like a novelty thing that some of these airlines will, especially Pan Am, will put together, and they'll say, "Hey, we're going to do a circumpolar flight. Be part of the circumpolar crew," because everyone goes east-west circumnavigation. Nobody does north-south, so they make a big deal about it, and they show these routes here. But again, we're projecting them on an AE, and we show that they're not going around the ball. They're not doing that. They're just doing a big loop. So here we got another one from Pan Am, big old loop. Then we have the One More Orbit crew who was going to do the same thing. Oh, look, a giant loop. Yeah, just a little loop-de-loo there. And then when they get called out for it on Twitter by our boy Gleam, they say, hey, you know what? The marketing team is using a concept image, and that's not the actual flight route that we took. Okay, thanks, dude. So no one's ever seen a transformation from a projection given to us from equirectangular like this that corresponds to what we showed in the original image there at the beginning. We got to go all the way back up to take one good look at it because we've never seen it before.
No one will ever see it again.
This
Never
one right
been
here.
presented,
These right here. So. All right, they've been showing it to us the whole time, and we just forgot.
Yeah, that's our evidence against circumpolar flights of GPS satellites, planes, etc., showing that they do that, which no one's ever done it, is our argument. We've shown you what it would look like if they actually plotted it. That's never happened. All
Yep.
they do is circle around the flat plane.
Yeah. And then so like in terms of like mechanism of like what is a satellite, what is the propulsion? Because here's the thing, you can definitely get a relationship with like satellitetracker.com or whatever, and it'll be like, this satellite's going to traverse the sky at this time, and you can actually see it or like get signals from it and stuff. You can confirm this stuff, right? But the thing with that is that the altitude isn't what it would be, and the speed that they say it is, it wouldn't have to be the speed, because if it was closer, it could be moving slower and clear the sky at the same time. But the way that it clears the sky based on the altitude that they give us, and because everything in the sky shares a relationship with Kepler's laws, including satellites. And that doesn't mean that there's mass involved. Mass cancels out, guys. But the periodicity relationship of when it's going to return to you in the sky is true. But that doesn't mean that it has to be at that altitude and that velocity. It can be closer and slower. So whatever they are, however they're propelled, however it works, couldn't tell you. But that would be my best argument against it, is that there's no circumpolar orbits, and they, claim mutual exclusivity over it, and they've never shown us one once, or terrestrially.
Yeah, I just found this video where somebody with a Pika balloon said it was able to stay up 735 days. Let's have a listen.
Wow.
35 days.
Yeah, hold on. I
Nice.
can actually share my if you'd like me to share my camera. Let me
Go ahead.
see. Okay. Launching of the W5KUB 18. Let's see.
SBS balloon. That's what our tracker looked like. This one went around the world 3.5 times. It was a solar panel.
It's just a single solar panel. That's awesome.
Tracker was taped under it. It's fixed to let the balloon go there. This is a very typical launch. We fly this balloon all the time now because it has the best chance of making it around the world and also staying up much longer. This balloon, one of these has been able to stay up 735 days. So
and then if you rewind it, here's some of the paths that they had going around this way. And then this one looked like it tried to go up and then looped right back down. So anyway.
Nice.
Very cool.
That is a long time to stay up.
We got a hand request here. Our boy Flat Earth Sub Guy. No?
Flat Earth Subgenius Society.
Yo, Dan, what's going on, brother?
Yo, what's up, dude? Good times for all, right?
Yeah, this guy's old OG right here, gentlemen. If you've never met him, Dan's a good guy.
Welcome.
No, I'm an obscure outcast in the flat Earth community, so just ignore me.
What's going on, man?
No, this has been a great show.
Yeah, these guys are smart.
This dude's a wealth of wisdom here. It's refreshing to listen to. It's one of the first GLOBEBUSTERS podcasts I've listened to in a while. I shared it in my groups and shit, but I normally just share things and I just go off and do my own reading or whatever. But I don't know. I've taken a long hiatus and everything, but seeing everything that's happened over the past month or two or three with everything, listening to this guy's cool. And my question's something I think he would be pretty familiar in. I have like really old books from I think like the late 1800s and early 1900s about spherical Earth trigonometry and planar trigonometry, and I haven't really looked into it too much, but I figure I might as well ask this guy. He seems like a bit of an expert on this.
Do you sell any of your books, Dan? I know you have so many books.
I'm just starting to promote me selling the books. I haven't.
If you guys are looking for old books, get a hold of this guy. He's got an amazing collection of books.
Really good ones. Any topic.
Too many books.
Any topic really too. The Luminethorous Ether. Admiral Byrd books, first editions, and it shows on right when you open up the very first page, it shows the maps, and it shows the uncharted, unexplored lands too. It's like on the very first page. It's like hello, but that was a Freemasonic expedition. But what was your guest's name? Sorry,
Dr. Mike.
Dr. Mike. What's up, dude?
And you can call me Mike or Michael also.
Well, I prefer to call you Dr. Mike. So, us subgenius refer to each other as doctors with a K. Could you give a brief explanation about the difference in accuracy between spherical Earth trigonometry and plane or planar Earth trigonometry? I could assume things, but I'd rather hear it from you if you can propound upon that or expound upon that.
So actually, that's not something I can expound upon. Just because I'm not, I haven't dug into it that deeply. I know it's there, and I've had to use it in classes, but I've never had to use it in real life. And one of the things I discovered really early on is there was a really steep forgetfulness curve for everything I didn't use very often. And so and for a while I'd like go back and re-educate myself on things I'd forgotten, but eventually I realized I have other things I'm interested. If I'm not using that, I'm not going to bother studying it to keep proficient in it. I don't consider myself proficient in globe earth Indie math anymore.
Oh, no big deal. Yeah, I was just enjoying it, and I was like, all right, what seemingly intelligent question could I ask to make myself seem intelligent here? But no, so
Good, I like this guy.
so I have but I have those. They're old as fuck, and it's like I collect any blatantly obvious spherical Earth, globe Earth stuff. I have all their space stuff, their space, what is it called? Astrophotography books. It's hilarious. It's all artist renditions and shit. I mean, it's seriously hilarious. Like, I have a shit ton of old official NASA books. And I mean, it's comic relief. It's literally like a comic book to me. It's like Garfield. You just reading. I mean, I think I was the first one to show the orbit of the rocket to the moon, and it was in the shape of balls and a penis. And do you know that picture, the orbit?
Yeah, I remember that one.
I
Oh,
pretended I was
from the moon landing or whatever. Or I
yeah,
vaguely
dude.
remember that. Yeah, classic.
I did that
Classic.
shit in
You
like
think they're mocking us with that?
2015. What's that?
Do you think they're mocking us with that?
Obviously, it's phallic worship.
Well,
It's
not us, but the general public. Oh,
absolutely.
look what these people are stupid enough to believe. Let's rub it in their face.
Yeah, no, it's obelisk phallus worship. It's the the rocket is the male energy, and the space is the infinite female energy, and the rocket is fucking space. So they just like to mock us with their weird heliocentric dark sorcery. I don't know. I don't fully understand it, but I can clearly understand the
They
symbolism
say
that
when
they're.
you stand at the bottom of one of these obelisks, if you stand at the right angle, it looks like it's a stairway that just keeps going up into the sky with that top little angle, and it looks like a stairway to heaven, supposedly. Yeah, the
As we
obelisk
speak,
is like the third pillar.
yeah, as we speak, I'm going through my book collection because honestly, I've stayed away from it for the past 2-3 years because my basement had a flood and destroyed hundreds, if not 1,000, of my books, and really expensive ones too. So I was
Man, that
pretty
sucks.
horribly depressed for a couple of years, and but I'm finally getting back to rearrange. I mean, dude, I'm still unearthing black mold in my books that I'm finding because they got stuck together in like clumps.
Mm-hmm.
So
I remember seeing your room and just books everywhere, just books piled on books on books on books everywhere.
What were you saying, Taylor?
Well, that was me. Oh, sorry. Were you talking to?
No,
Let you go first. I heard you mention you have luminous ether. Was that the 1886 DeVolson Wood version?
I'm seriously, I'm going around and looking right now. Right now, I'm staring at Flammarion book of astronomy. That's it. And it's like
I
the original too. It's an old big ass book here I'm staring at. Actually, shit, I can do a video here.
I read the original 1886 DeVolson Wood version, and he was pretty far off, but he was definitely on the right track. And when I found out what the actual pressure and density of the ether was, I was blown away by the magnitude of it. It was way, way higher than he ever imagined it could possibly be.
Oh, there we go. Hello.
Oh
So-
yeah. Well,
Oh,
I did have a question. I might as well just ask it now. So in the Admiral Byrd, I was just curious, did he go past the ice wall or did he go inside the Earth?
I'm not sure. I'm not sure. I can only speculate. But you guys are familiar with this one?
Never heard of her.
This is a famous one for globe heads. Can you see it, right?
Yeah, it looks good.
Okay, cool. Let's see here. We got that's not how you
We
open
just
up
got to
books,
get you a
right?
Toby so you can scan all these old books to make them available for me for free without getting off my couch.
Yeah, I mean this is only 1964, but I prefer to get it before the moon landings, supposedly, because it's so much. There's so much more gold in the books before the moon landing. But yeah, so great scientific popularizers of the 19th century and astronomers, so brilliant. She popularized.
Sort of genius, I forget his name, but I think he was asking about the math between planar and spherical trig. That's one of our
So
other
look-
favorite points. Is this literally it's identical? The only thing that's different is the fundamental plane has a negative value when the thing that you're trying to record is not visible, right? So instead of going along a circumference along the plane of Earth beyond your vision, you could say it's actually at the same circumference beneath your feet, and the math that will predict it will work exactly the same. So you give it a negative fundamental plane value, and you can use hemispherical coordinates to predict everything in the sky.
Damn, that's
Yo,
pretty badass.
Speaking of that, we're gonna wrap up here soon in about 5 minutes. So
Okay, cool. I'll just show this real quick. That's what I mean. Like, just you can tell.
Another excellent presentation, Dr. Mike. Thanks again. By the way, this was epic. We took it
There you go.
preemptively to TikTok to see how the globes would respond, and right now their best response was they confirmed all your math was right, but they didn't believe that was the measurement from on top of the mountain.
So look, before I get out of here and have you guys wrap shit up.
Not surprised.
So look, you got.
They took a while to confirm the math, and when they got there, they were like, "Well, this is right, but you still must be wrong, so you didn't measure it." That's what I concluded.
There's almost 700 pages,
When
and
they
you can.
follow my instructions
Oh shit!
and
Am I on mute?
replicate my results, going to be witnessing a lot of meltdowns.
yeah.
Yo, could you
It's
guys
gonna be
see
awesome.
this?
Yeah, we could see it.
All right, so yeah, like this, just like globe Earth. If you need globe Earth pseudoscience, you just go to whatever chapter you're interested in. Somebody was asking, got the Earth satellite, the moon, phases of the moon. You got the how the Earth revolves around the sun. It's just, it's
Nice.
so ludicrous. The
Yeah.
eclipses of the sun, inside the sun. They know what's inside the sun, guys. And it's just, I don't know. It's just so, and then it's like they show a flat Earth. But
from the side, slightly tilted.
But yeah, so thanks for letting me on. And
yeah, it's good talking to you again, Dan. It's been a while, man.
Yeah, absolutely, dude. Yeah, I'll have to do, like, as you can see, I have to organize this stuff. Like it's
like I said, books on books on books.
You see that?
It looks a lot more organized than the last time I saw it, at least.
It's literally
better shape.
Endless amount of books here, guys. But and the ones that are in the boxes are the ones that like these ones right here. Yeah, I can't even. They're thousands of dollars.
All right. Well, we're about to wrap up here. Shane, what do you got coming up this week, buddy?
Nothing, or everything that you have coming up, probably.
All right, cool. So I'll exit us on the way out. Dr. Mike, you got anything coming up, sir? Where can the people find you if they
No,
need to
sir.
contact you for questions? You have a contact email or anything like that you want to put out, or a Discord or anything?
Um,
I have to.
they can
but-
definitely contact. Yep, they can definitely contact me through Discord, and they can reach me through michael.heffron@acm.org.
Awesome. Awesome. Sounds good.
That stands for Association for Computing Machinery Organization.
Nice, nice. Awesome. Zach, what do you got coming up this week, buddy?
Same as usual, Monday, Wednesday, Friday, Iron Realm Media, 5 a.m. Eastern, early bird show. Have a lot of fun. Just make fun of the government and space and whatever's going on. It's been insane lately. I've heard a lot of things I've been calling for 20 years to happen. And then I'm hearing some real crazy stuff to go along with it that I don't really like. So I don't know. It's interesting time to be alive, to say the least. Remember, folks, it's all a show. Just sit back and enjoy the ride. Don't get emotionally attached to politics. Look at it like you watch a TV show, and it's a lot more fun. I'm just telling you. Don't pick a side. That's what they want you to do. Yeah. So yeah, it's getting really exciting out there for those who follow politics. And yeah, the show never ends. It's just gonna keep, it's that show. But yeah, that's what I'll be doing. Nope. You muted, Alan?
Taylor, what do you got coming up this week?
So on Tuesday, I'm going to be presenting on abiogenesis at 8 p.m. Eastern. Is that correct?
Where's that?
8
at,
p.m. Eastern. Where?
Cool. Right here on Ether.
Right here on the Ether Cosmology Discord at 8 p.m. Eastern. You're gonna take apart one of the pieces of microevolution that's supposed to support macroevolution. Is that my understanding?
Yep. Like basically how life could not have started on its own.
And you're gonna do a multi-part series, you said? No time commitment as of yet, but you're gonna systematically destroy evolution, you said?
I absolutely, but I think that this presentation might be too long because there's so many ways to destroy it. I'm literally not kidding. Like I might have to break it up, but I'll let you know tomorrow.
Have you not seen
Nice.
Alan's first presentation? Never mind. You're fine. It's fine.
My first Prezi was 4 hours long.
Oh gosh. Yeah. I'll
My
see.
second one was 4.5 hours. It got longer.
Yeah, you're fine. You're
How
fine.
did that happen? You're gonna do great. All right, cool. So that'll be Tuesday. Monday will be some variation of game night we will play around 10 or something, I think, Eastern. And then what do we got after that? Wednesday and Thursday will be our TikTok nights. Wednesday will be raid night, and then Thursday will be our follow-up community space. And then Friday, of course, may or may not be the return of a certain duo Android co-hosting situation that is known to be prolific on Twitter, that hosts a space that rhymes with Flat Earth Lie Day or whatever. Flat Earth Friday. I don't know. Anyway, so hopefully that returns. But if not, we'll do a little community space. So we'll see you guys then. Have a good week, everyone.